I'm old enough to remember when we loved the sun and then we hated the sun for the majority of my life. And all I've watched is people get sicker and fatter and more metabolically compromised throughout the entirety of my life. And I'm just like, okay, humans are not doing so good. There's a piece missing here. There's several pieces missing. But I think, even if people just went out in the sun more often and did so safely and intelligently, there's ways to do this without burning the hell out of yourself. I think we would see rates of metabolic disease plummet. I mean, it's insane. Let's talk about that. Let's talk about the basics of this.
Yeah, for sure. So, I mean, metabolic disease is probably one of the biggest things. And, it ultimately comes down to your mitochondria, right? So your mitochondria are these little organelles inside of every single one of your cells, besides red blood cells, because they don't have mitochondria, but every single other one of your cells have thousands of mitochondria inside of one single cell. You have trillions of cells in your body. So you can just think you have so many mitochondria. And these mitochondria are basically these little organelles that basically are little batteries, right? So your mitochondria have an inner mitochondrial membrane, and across that membrane is a charge gradient. So you basically have this voltage across the membrane, and these electrons come down the electron transport chain to essentially produce, what we said, ATP, adenosine triphosphate, which is the energy currency of the cell. And the higher this charge gradient in the mitochondria, the more ATP that is going to be produced, and then the more energy that is available to the body and to our cells. And when we look at light, so there's some amazing research out of University College London. Dr. Glenn Jeffrey, he's done some great research on this, where we're looking at longer wavelengths of light. So the sunlight spectrum spans from UV all the way to far infrared. UV, short wavelength; red, infrared is just beyond red, is long wavelength light. And these long wavelength light basically are able to increase this charge on our mitochondria, thereby increasing ATP production, thereby having more available energy in the cell, and also just healthier mitochondria in general. And when we look at every single disease, cardiovascular disease, cancer, you name it, diabetes, it all comes down to it's metabolic disease, right? And it comes down to your mitochondria. And if you have unhealthy mitochondria, unhealthy in the loose terms, mitochondria, then this is what creates disease. And so there's a few different mechanisms here, right? We have so red and infrared light on your mitochondria. You have these protein complexes. One of the protein complexes is called cytochrome C oxidase. Cytochrome C oxidase is basically this chromophore. Chromophore is just something that absorbs light. Cytochrome C oxidase absorbs red and infrared light, releasing nitric oxide, allowing electrons and protons to funnel through, push protons against the gradient, have a higher charge on the mitochondria, producing more ATP. And that's one mechanism. There's also, the mitochondria is so awesome. You have the last protein complex is ATP synthase. It's this little motor, and quite literally a motor. At the end of it, it's this little rotor that spins really, really fast. And at every single spin, you have one ATP that's produced. And so this rotor also has water around it, and the water is viscous. So if we can reduce the viscosity of the water around the rotor can spin faster, right? Makes sense. You have lower viscosity. The rotor can spin faster, thus producing more ATP. And that's exactly what infrared light does. So infrared light can be absorbed by this water around ATP synthase, reducing the viscosity of the water, and then ultimately producing more ATP. Those are the two main sort of mechanisms at play here. Dr. Glenn Jeffrey, Bob Fosbury, Scott Zimmerman, and Dr. Roger Schwelt. They're these four researchers sort of in different silos of the space. One is a quadruple board certified physician out of California. One is just, a fundamental wet lab researcher. One is an astrophysicist, and one is a lighting engineer. And they sort of come together. They're putting out a paper soon where they have a new sort of hypothesis of what's happening. And what it basically is that the infrared light sort of acts as a lubricant in this electron transport chain of the mitochondria, simply allowing the electrons to funnel through faster. So it doesn't have anything to do with cytochrome C oxidase, doesn't have anything to do with the nanowatt around ATP synthase, simply allowing electrons to funnel through faster, and thus increasing charge gradient, increasing ATP, having a healthier mitochondria in general. We want that charge, those electrons to flow properly. There's this concept of energy resistance. So Dr. Martin Picard out of Columbia University, he's published a great paper with his wife, Narosha, where it's called the energy resistance principle. If we have too much energy resistance in a system, if energy cannot flow properly, that's what is fundamentally at the root cause of every single disease.